Okay, so, when we talk about redox, we talk about these metallic ions, okay? Metal ions are relevant in biology, okay? What was an example of a protein that we saw, not cytochrome C or redoxin, that had a metal ion? Hemoglobin and myoglobin, right? We had an iron atom attached to a heme. Perfect. So metal ions are involved in many important biological redox reactions, okay? They're basically the site on proteins where they can participate in this redox, okay? These ions are bound to the protein molecules either via a heme group or sometimes via iron-sulfur clusters, okay? A bunch of bonds between a sulfur group and the iron. They're not diffusing freely in solution. You could have metal ions floating around, you do, but not that are participating in the types of reactions we're gonna care about, okay? So then the proteins will arrange themselves, okay? They will use their folding, tertiary and quaternary structure, okay? Their overall folding and their interaction with other proteins in sort of two ways. One, it allows these redox active centers, it allows these metal ions to actually come together in close proximity and participate in the reactions that we're interested in. While at the same time, then they're usually buried inside the protein in maybe a flexible spot that can open up and interact with some other protein. And that's protection for the metal ion, so it doesn't participate in any undesirable reactions. Okay. And here are two more examples in addition to myoglobin and hemoglobin. Again, you don't need to memorize any of this. I mean, myoglobin and hemoglobin, sure, we've talked about them enough that I would expect you to have like a clue about their generic structure. 4 subunits versus 1 has a heme, has an iron, but you don't need to memorize these by any means. You don't need to know that there's like a 3 iron cluster with sulfurs here and redoxin and 4, like, I don't care about that, okay? But nevertheless, there are several proteins, many proteins that will have metal ions.